The life of a PhD student studying glaciers is not a typical life, and it might be hard to know what a typical day looks like. So I'd like to tell you about what I do at work on any given day. First, I'll show you where I work. Here's a map of the Ohio State University. Main campus and the football stadium are over on the right of the map, but I work at the Bird, Polar, and Climate Research Center on West Campus on the left of the map. Here's some footage of me walking up to my office. West Campus is very pretty and very quiet. I don't need to take classes anymore, so I usually work about a 40-hour work week here in my office, mostly doing research. I study how the floating ice shelves in Antarctica are affected by features called basal channels, which are like upside-down rivers that cut up into the bottom of the ice. More on that later. Coming up to the building now, this white-roofed building on the right is the Bird Polar Ice Core Library. There are miles of tubes containing segments of ice cores from all over the world stacked on shelves in this giant freezer, which people from all over the world can use to study past climate. I don't do anything with the ice cores, but it's very cool that we have this library here. I'm in the building now, and you can see that there are posters and photos on all of the walls. You can learn more about them if you ever take a tour of Bird, but they highlight the research and the fieldwork of our current scientists and some of the early polar explorers. My office is here at the end of the hall. Inside, we have these beautiful prints of glaciers on our walls. My lab mate Michaela and I took all of these photos, and they made the office a really nice place to work. I'm the only one in today, but here we're making our way to my desk. One thing that's really important to me as a grad student is helping to make sure that diversity and inclusion are top priorities in science departments. So to illustrate that, here I am tweeting about a new program through my professional organization, the American Geophysical Union, that helps underrepresented minorities thrive in grad school. I also get email alerts about cool scientific articles, so I'm going to open one up to read it later. Now I've switched my screen over to MATLAB, a coding program that helps me organize and visualize my data about ice shelves. This is how I do research. All of my data comes from satellites and airplanes, and I can download it all from the internet, and that's what I'm doing here. I'm using a MATLAB code to specify where I want to grab digital elevation models, which are like pictures of the height of the ice at different times. And the ice shelf I'm focusing on here is the Nickerson Ice Shelf in West Antarctica. Skipping ahead, the data is downloaded, and zooming in on the Nickerson Ice Shelf, you can see the outline of all of the digital elevation models I've downloaded. This is about 5 gigabytes of data, which I'm going to save for later. Now I've processed the data, and I'm going to look at it to study ice shelf elevation change. I do this by taking 2 overlapping digital elevation models from different times and subtracting one from the other to see the difference between the 2 times. Here, we see the rate of elevation change between 2011 and 2015. The blue means that the elevation is lowering, so the ice is getting thinner. Now, I've put the location of the basal channel in different years on. This particular channel doesn't look like it's changing a lot because the colored lines are all in about the same place. I do this kind of stuff all day long, and I do it for several places and around Antarctica. I record my findings so that I can publish them in a scientific journal. I've already submitted my first scientific paper, and hopefully it'll be published soon. I'm also on the executive committee of 2 graduate student clubs on campus, and I am very active in the Earth Science department at Ohio State as a graduate student representative, so I have a lot of meetings to go to each week. In some semesters, I'm a teaching assistant, so I spend about 15 hours a week teaching students Earth Science labs and grading their work. In the semesters when I don't teach, I'm either a research assistant or grad student fellow, so I can spend all of my time doing research. I hope this helps give you an idea of what my job looks like. Thanks for watching.